Instead of rocket-powered suborbital flights like those of Virgin Galactic, could high-altitude ballooning become the most viable way of letting paying tourists experience space, or at least something thrillingly close to it? Ballooning is already tried and tested technology. It's the origin of space travel, explains Amelie Schoenmacher, External Relations and Legal Officer for Zero to Infinity, a Spanish company that plans to launch passengers to near space using balloons known as balloons for €110,000, $124,000 a time. Zero to Infinity is one of two organizations hoping to use pressurized capsules suspended beneath helium balloons as a way to take tourists into near space. Flights using helium-filled balloons began in the early 1930s. For me, this time was what I call the first space race, as it was the first time we went into the stratosphere, explains Dr. Jonathan Clark, an associate professor in neurology and space medicine, who has advised on both Red Bull Status and StratX, the project that saw Google executive Alan Eustace make a record-breaking space dive, assisted by ballooning company Worldview Enterprises. To this day, ballooning is hugely important for space science. NASA and other commercial companies use balloons as an inexpensive means to test payloads in near space environments. Because balloons can spend a relatively large amount of time in the stratosphere, this gives increased observation and experiment runs, explains Jane Pointer, CEO of Worldview, which will offer near-space ballooning trips for $75,000. High-altitude ballooning even has some high-profile fans within the space community, including veteran of 4 space shuttle missions, Mark Kelly, who works with Worldview as Director of Flight Crew Operations. Of course, it's not actually space. Balloons only travel to a height of between 30 and 40 km, with 36 kilometers being seen as optimum. To reach what is defined as space, you need to travel to a height of 100 kilometers. You are still high enough that you are above 99% of the Earth's atmosphere, and although you don't experience weightlessness, you are able to see something that most humans haven't, the thin blue line of the Earth's atmosphere. Passengers would also be able to see the Earth in the blackness of space, as well as the sun rise over the curvature of the planet. The science behind sending humans to the edge of space is much the same as sending any other payload. The capsules are completely sealed, allowing for full pressurization at altitudes. Balloons can in theory launch from anywhere in the world, as long as the weather is favorable. Unlike rockets, there is no big acceleration, with a balloon taking between 1.5 to 2 hours to reach maximum altitude. Once there, inside a capsule attached to the balloon, crew and passengers can bob along on the edge of our atmosphere for up to 2 hours. Once built, both the balloon and Worldview cabins will have toilet facilities, and you'll even be able to dine on board. To return to Earth, helium is vented from the balloon, then a para wing, which is already deployed, takes over the remainder of the descent. Schoenmacher explains, for safety, we also have a further 2 backup chutes. With the capsule landing in a predetermined location, guided back to Earth by a pilot and the support of mission control. The ultimate aim for near-space ballooning is that the experience will be comparable to getting on a commercial airliner. Passengers would be inside a pressurized environment, just like on a plane. However, whether passengers would still need to wear spacesuits will depend on certification from authorities. As with other forms of commercial space travel, in the United States, balloons to the stratosphere are regulated by the FAA, Federal Aviation Authority, under the Office of Commercial Space Transportation, although for flights in Europe, regulation is not yet defined.